door basically. So these are your
Okay.
instructions right here.
Yeah, I see it. Okay, let's see.
And so
Oh, I'm gonna add a comment on line 8 just so we can run the file. Oh, nice. Oh, that's a nice door. Holy crap.
yeah, I spent a little time on it.
Damn. Okay. All right.
Yeah,
As a
once you
reward, I'm
showed
going to
me
show
all
you.
the
Hmm?
nesting stuff, I was like, oh, now I know how to draw what I want. Okay, cool.
Yeah. Like in theory, right? You could literally draw anything. Yeah.
hmm
Okay. All right. I'm going to show you something cool now. All right.
Okay.
Watch closely. I'm on the 2026 0810 homework hw.arr. I'm
Oh,
at the
oh, you're on the
bottom.
homework. Okay.
Oh,
Hold
wait.
on.
Is there another file for this?
Yeah, I set it aside in the homework, but I'm on like 8.3, the 8.3, 2026 8.3 one-on-one because you said you wanted it all together.
Okay. Okay. All right. I'm going to hit over.
And then it'll be like down the 250s,
Okay. I see it. Okay.
but it's
All
the
right. I was
same
on the
thing.
wrong file just now. Okay. Okay. I'm going to show you something cool. Okay. So I'm going to show you something. But I'm going to show it for door, and I want you to do what I did for traffic light, okay?
All right.
All right. I'm sounding vague on purpose. So the first thing I'm going to
Gotcha.
do, I'm going to write reactor, okay?
All
So
right.
reactor, it's red. Notice how it's red. It's a bit special. So a reactor, it can take, it's going to look very different. First thing I'm going to write is init, short for initial.
Yeah.
Um, I'm going to I'm going to leave blanks for now. It's initial something, initial what? Okay, let's come back to that. Next thing that this reactor needs is, oh, I need to close this with a comma. Uh, I believe it's called on mouse. Okay. So
Okay.
this reactor, it can react to mouse inputs. Okay.
Okay. So clicks. Got it.
Last thing I'm gonna do is to draw. So whatever this reactor thing is, it can draw stuff.
Okay.
Oh, there are other things, but for our purposes, these are the three things that we're gonna work with. So here's what I'm gonna do. I'm going to make a GUI app where we can open and close our door.
Yeah.
Okay.
Okay.
So the reactor, internally, it has like an understanding of what's happening. It has a model, a state. So it has a model state, give whatever name you want to call it.
All right.
Um, so in our case, let's say we are working on a door. For the initial, is the door initially open or closed? I'm going to say the door is initially closed. So I see you called it pause closed. All right.
Yeah.
Here on mouse, it's actually a function.
Okay.
So on mouse, I'm just going to call it on mouse door for now. And so we'll need to define this function.
Okay.
It's not on mouse door. And what does it take in? What does it produce? We'll find out in a minute.
Imagine some kind of input.
Okay, yeah, let's do it right now. So what does it take in? So the first thing it takes in is, I'm pulling out the documentation because I also don't remember. Let's see. Don't remember exactly. Ah, yes, okay. A N N string A. Okay. For all purposes, it's going to take in a door. Next, it's going to take in two numbers. It's going to take in a key event. It's going to produce a door. So door.
Okay.
So the two numbers are X and Y, the two positions of where the mouse is clicked, and a key
All right.
event. I'm going to fill this in a moment. I'm going to leave it blank for now. To draw, how are we drawing the door? So to draw is it takes in a function. This function must
Mhm.
take in a door to an image. I believe you have a draw door operation.
Yeah, I
So
have
I'm
one
just
for
gonna,
the door and one for the frame.
is there one altogether?
No.
Wait, so
I
like,
suppose it could
oh,
make
I
one
think draw
altogether.
door operation does it all, right?
Oh
No?
yeah, yeah. The draw door operation is like if you enter the position, it will draw the door open or closed depending on what you enter. So yes, that does that.
Cool. Cool. Okay. All right. So I'm going to plagiarize your function. I'm going to say that's how we're going to draw the door. So let's go back to on mouse door. So there are a few key events. So you know how like when we want to draw a rectangle, we need to pass in a string color or whatever.
Yeah.
So this is the same thing, except we are we are not calling this function. The reactor, whatever it is calling this function for us. Okay.
Okay.
So in our GUI app, when we click on something, this reactor is going to call on mouse door. It's going to tell us what's the current state of the door, the X and Y position of the mouse click, and the key event. Okay.
All right.
There are a few key events. The one I'm going to use is button down. So
Button
if,
down.
yeah, so this is in the documentation. I'll show it later. It's
Oh, okay.
this.
Button down. Now that I see it written, I understand what you mean.
Yeah,
Got it.
button down. And what I'm going to do is I'm going to activate the door when the user clicks on it. So I believe you have a function I can plagiarize. So it's called activate. So I'm going to call activate passing a door. Otherwise,
All right.
do nothing. Okay. See that?
Yeah.
All right. Let's see if this works. Ah, damn it. What did I do? Oh, gets me all the time. I didn't write n. Cool.
Mm,
Okay, so nothing has happened. So the same, remember, like it's like what we just did is like defining a function. We have the
yeah.
thing, but we didn't use it. So to use it, first I'm going to assign this to a variable anim, and I think this is the syntax interact anim. So I call interact on it, but it's unbound because I need to import it. Give me 1 second as I include reactors. Okay.
Do I need to import it on my side too?
Nah, just I just have to write it at the top of the file.
Got it.
So at the top of the file, I'm going to write an include statement that will include a library. And if you click run now, I believe you'll see a door. It's kind of,
Okay.
do you see it?
Yeah.
I don't know about you, but my door is like really big. Like
I mean,
it's
it's like it's the size I made it.
okay,
But
yeah.
I think I'm using like my window is much bigger than yours. I can tell like you know how do I say
Oh,
it? Like
yeah.
I can see 178 lines of no yeah about 172 lines of code, but you can only see about 20 in the
What?
window.
Wait, do you have one of those tall monitors?
I actually have a really wide monitor. I have like a Samsung G9.
Oh,
It's like 1440p. It's nothing crazy. It's not 4K.
okay. Anyway, I'm trying to open and close this door, but it's not working. I think something is wrong here. It's on
We never
mouse
made
door.
the mouse click event, no? Didn't we have to make a function for that?
Yeah, I did it on top, but I think oh, okay, so here's the problem string. So it's on line 266 on mouse door. Do you see that?
Yeah.
So I just read the documentation. So here's the problem with strings. You can make typos. I made a typo. It's not button
Mm,
underscore down. It's button hyphen down.
there you go.
Now we run it. Okay, now click on the door.
And there you go.
Oh, I
There
just
you go. I
closed it,
can
but
close it at least.
I can
I
open
can
it now.
close it, but I can't open it.
Wait, what the heck? And why is this following me? I'm so confused. Oh, the heck? Okay, let me kill this. Okay, wait. Let me see the test for activates. Oh, wait a minute. Activate produces a string.
Y- yes.
Is there a
What
version
was
that
it
like
supposed to produce?
was it, is there a version that swaps? Like if it's open, it becomes closed. If it's closed, then it opens.
I mean, like that's how I interpreted your instructions. So
Oh, oh, okay. Sorry, I think
okay.
yeah. Could you create a another function that's like that like swaps. Like if you pass in an open door, it produces a closed door and vice versa.
Okay, so when you say it produces a closed door, because we're not drawing it this time, what does that look like in this activate function?
So like if we go to the traffic light, rotate traffic light, it
Yeah,
produces a traffic light. Like we produce bot, top or mid, right? On line 96.
yeah.
So it's like rotate traffic light but for the door.
Okay.
All right, can we
I'm
do that
gonna
real
have to
quick?
make a new. Yeah, yeah, yeah. Okay, so I need a. No. Um. Okay. Is.
Where are you at?
Oh, I'm working on line 208.
Wait.
I made a new variable on line 193 for the open position
Okay.
because I really my the way I set mine up, I really only needed one variable because mine are either like it either is closed or it's not closed. Um, but
Okay.
so I made a new variable for the open position, and now I'm setting it up where instead it just returns that variable, which is just the sentence open or closed. Um, so now I gotta. Okay, I'm just gonna. Mm, close, open, close, close. Okay, I think that meets what you're asking for. Does that sound look right?
Yeah. I believe the test cases for activate, um, I'm seeing like wide open or ajar.
Oh, I just like however you enter the position of the door. Like if it's anything but closed, it's gonna show up as closed. Like, oh, it's
Okay.
open, so I'm closing it. And then if you're ending the position as closed, the door ends up open.
Oh.
I also updated the
Oh,
traffic
okay.
light things.
Okay. Sure. Um, I I do want to say if you want to do that, the data definitions might be a little bit off. Oh, wait a minute. Okay. So we're missing a data definition here. Okay. So let's look at lines. Let me find that. So let's look at line 64. We see a traffic light is one of red, yellow, green, right?
Yeah.
So I want to see something like this, but for the door as well.
Okay.
So in your case, the definition, so based on what I heard, it sounds like a door is one of closed or a string other than closed.
hmm
So I want to see that as well. So this is the first step of the design recipe, right?
I, if I'm honest, I don't know I don't understand how all the orders like situated. I just know like, okay, I kind of look at them out. I gotta put a purpose and input and output type.
Okay.
Let's see. Huh? Red, yellow, green. Okay, that's fine. Were these all just commented out one line at a time, or do we? Oh, that's right. We used that thing to remind me. Okay. Uh,
Cool.
okay.
Okay. So you're saying the door is one of open or closed, right?
Yeah.
Perfect.
Or should I
Okay.
say door position?
No, door is fine.
Okay.
Um, so Door or door position is fine, and you just stick to one, but I think door is perfectly fine to me. Another thing that I'd like to see as well is a signature for our functions. So if we look at line, let's say line 94,
Okay.
so we see the rotate traffic light. On line 94, we see the signature function. It's saying the inputs and outputs of the function, right? Takes in a traffic light and produces a traffic light.
Yeah.
So yeah, that's something I want to see as well for rotate traffic, not for future functions that you write. In the case of rotate traffic light, we see traffic light to traffic light. But what would be the signature of um, activate?
I would say door position to door position.
Door position, door position. Okay. So uh it's you're saying like it takes in a thing that's either open or closed, right?
Yeah.
What's the name we assign to the thing that's either open or closed?
Um, what, the door?
Door, right? Line 192,
Yeah.
DOOR. So we want to keep this naming consistent so that when people read this, they know, oh, you're referring to the thing that's either open or closed. See that?
Sure.
Yeah. And let's move line 199 to the top of 215. So just right before fun activate, let's move that there.
Okay. Oh, I see. So what line? 215?
Just right before line 214. Yeah, that's perfect. Okay, so in the future, when you write functions, I'd like you to have this line as well, what it takes in and what it produces, using the names that you have established earlier, right?
Got you. And then up above in
Mhm.
line like 192, what are those called again?
192. Like a
Yeah.
door is one of open or close.
Yes.
This is our data definition. Yeah. Wait, I don't know if I explained this part. Like, what is a data definition? Did I go over that?
Um, I think so. But I get data definitions are the I guess the available data types. Put it that way.
Yeah. Did I
So
show you
like
a
what?
diagram with
Base.
circles?
I don't think so.
Okay, yeah, I don't think I
Um,
showed that to everyone.
it's like what you're enumerating through basically.
Yeah, so in our case, that it's what we're enumerating through. So I'm gonna share my screen. Could you sh
Sure.
stop sharing yours for a second?
I don't think I'm sharing mine. All right. You're
Oh,
sharing your screen.
brain fart. Sorry, I'm the one. Yeah, yeah, okay, sorry. My bad.
No worries.
Okay. So let me change this to my. So I'm just sharing my whiteboard here. Let me know once you see it.
Okay. I see
See
it.
it?
Hmm.
Okay. I want you to picture the universe, but not our
Okay.
universe. I want you to picture the universe of our programming language.
Okay.
More specifically, the universe of data.
Okay.
In this universe, there are many, we have like one, two, three, so on, right? That's a lot of numbers.
Hmm.
So numbers are a data type that we have in this language.
Hmm.
We also have true and false. Remember that?
Booleans.
Yeah. We have strings. We have the hello. If you remember our first session, hello world.
Yeah.
We also saw like blue, green, and okay.
Hmm.
So when we refer to a data type of this programming language, like numbers, what we're doing is we're drawing a subset. We're drawing a smaller circle around the universe of data, right? So like
Okay.
one, two, three, and well, that's a lot of numbers. And excuse my handwriting, I'm using a mouse.
Yeah. No
So
worries.
we can name our subsets, right? So this is our real numbers. This is our data type. So when I say number, you know what I'm talking about, right?
Yeah.
Now you can't name every single number, but you can still know what I'm talking about.
That's right.
So same thing, we can say when I say booleans, we're drawing around the circle around true and false. Now the interesting thing about booleans is that true and false are the only two uh, values in this data type. So this circle is only going to contain two things, right?
Sure.
And we have strings. Anything within double quotes are strings.
Hmm.
Um, and so we have strings in here. Okay. I'm not sure if you're familiar with set theory,
Set
but th
theory? No.
yeah. Well, for all purposes, it's drawing circles around things, right?
Okay.
So this big box is anything that we could draw circles of. Everything's contained inside this big box. There's nothing outside this big box. And our circles, we're drawing subsets. We're like grouping together small individual things in our big box of things. So, for example, R contains all the real numbers. But whenever we draw a circle, there's also the stuff outside that circle, right?
Okay.
So in set theory, at least, we put a line on top to say the complement of. So everything outside of the circle, the R circle, is not a real number. So true and false, hello world, blue, green, then none of them are numbers. Okay?
Yeah.
Um, so so data types, another way of understanding data types is where you're drawing a circle around the values belonging to that data type. If you can draw that circle, it's a data type. For example, like if you draw a circle like this, like let's say tree and hello world, like what is the rule for that circle, right?
Mm. Yeah.
So to summarize, actually no, before I tell you the summary, let me show you another thing. So blue and green, we can also draw smaller circles inside of our circles. For example, here, that's a bad circle, sorry. Uh,
Yeah.
this is our
But no.
colors, right?
Hmm. Yeah.
So within our strings circle, we have an even smaller circle that's our colors. We also have, oh, I'll use the traffic light example. It's like red. Oh, funny. I'm saying red, green, blue. I'm gonna.
Yeah. You can make a subset of those three.
You already know, huh? You
Hmm.
already know. Does this look familiar?
Yeah, of course. Yeah.
Our traffic light, right? This is our traffic light data definition.
Yeah.
A traffic light is one of green, red, yellow, all the way down. So to summarize, a data definition. Oh, okay, wait. A data definition is a well-defined circle. Okay?
Okay.
You can draw a circle. So in the case of traffic light, we draw a circle around green, red, and yellow. So by well-defined, we can confidently say what does belong and what doesn't belong to that data definition. Okay?
Hmm.
Now the reason why name so just now I was like very strict about the naming. Like when you say door position, I was saying, oh, let's keep it consistent. Let's just say door. The reason why we want to keep our names consistent is because we want to be able to identify these circles. Okay?
Hmm.
Just like in real life, if a person has a name, you want to call them by their proper name, right?
Yeah.
Otherwise, when you call their name, you're not gonna know you're talking to them. So same thing here. So a data definition is our ability to draw a circle. And so like we can now talk about that circle specifically. For example, like when we're talking about traffic lights, when I say traffic light, I'm talking about one of green, red, and yellow, right?
Hmm.
Yeah. So
Yeah.
yeah, another way of saying this is okay, I don't know if this is another way, but this is a way of saying this. A data definition allows you to create samples that belong to that definition. Okay. And this is important later. For now, it just sounds like common sense, but trust me that this is important.
Okay.
If you cannot create examples of that data definition, it is not well formed. It's broken. That's not a good data definition.
Okay.
I know it's like, wait, how is that possible? Trust me, it's possible. It's possible to create a data definition where you cannot create examples, and we will see that maybe in 1 or 2 sessions. All right,
Okay.
I'm gonna
So
go back to VS Code. Yeah?
to take our current thing, like if you're starting with doors to position like open and closed, and those
Yep.
would those be the examples, like oh, an open door, a closed door.
Yes, yes. So I'm gonna go back to VS Code now. Uh, so what I also want to talk about is we've said that our door is either open or closed, right? But let's look at line
Yeah.
226 and 227. We see wide open and ajar.
Hmm.
Now we have to make a decision. Do we want to allow things like wide open and ajar to be doors?
Got you. Well, I guess it doesn't make as much sense. I mean, it still could be fine because of the way I set the code up. I set it up to be able to take a wide variety of inputs and still
Yeah.
come up with appropriate, like returns.
Yeah.
But
Uh,
but for the kind of for what you're going for, no, I get
okay.
like, hey, you want to stick to A and B.
Okay. So yeah, actually, let's discuss this while we're talking about here. So what you're talking about is design decisions. How do we want to represent a door as open or closed? So this is actually a valid choice. It's either closed or if it's anything other than a close, sorry. Yeah, if it's closed, it's closed. If it's anything other than a closed, it's open. That is
Yeah.
totally valid. Um, and so you have to justify that. But so right now, let's say you and I, we are partners in a business and we're writing a product. And so we have a discussion about this. And so I might bring an argument and say, wait, so could people pass in the string banana into this function?
Yeah, I guess they could, and it would break the function, I suppose.
No, it would not break. It would work. If you pass
I
in
mean, it would
banana,
work, but like it
yeah.
wouldn't make sense, is what I'm trying to say.
Ah, okay. So now we're talking about like maintainability and readability of the code base, right?
Sure.
Yeah, so they're trade-offs. So on the one hand, it's more flexible, it's more durable. It's you can't break the function. The function will work no matter the string you pass in. But the bad part about it is readability and maintenance. If people are passing in things like banana or apple pie, things are pretty hard to understand, right?
Yeah.
Okay, this is like a topic that's way advanced, way ahead of us, but I'm glad that you brought it up. It is a good thing to think about it. But for our purposes, as you said, you can tell I'm leading you towards just having one of two choices, right?
Yeah.
Yeah, so let's do that. Let's just stick to open for now. Can we fix 226 and 227?
Sure.
Yeah. Ah, the consequence of this is that there's only like two ways to call this, right?
Yeah.
Okay. And could you also fix the template? Let's be more strict.
Sure.
I think that oh yeah, that's fine. And a 207 as well.
Oh
Right now
wait,
that's saying yeah.
actually, you're right. I did do that wrong. This is the one I gotta change. If
Cool. Okay. And anything that uses this template must also be modified.
right, and I think this one does too. Okay, we're good.
Cool. All right, I'm just running the door right now and we can open and close it. You see it?
Yeah.
Yeah. All right. Nice. Nice. Okay. So I'm gonna recap what we did with the reactor again, since that is a while ago. And I'm gonna ask you to apply that to our traffic light. So I'm gonna do a quick recap at line 298 now, at the bottom of the file. So
Okay.
recap. So first, I wrote the reactor blah blah blah. I just wrote that. Second, I wrote init on mouse and to draw. After that, I filled in init is pause closed. Next, I filled in on mouse with on mouse door, and I implemented that too. And then finally, I did to draw is was it draw door operation, which you have kindly provided me. And finally,
Hmm.
I did anim equals reactor. I assigned it to a variable. I lied, that wasn't finally. This is finally. I did interact anim. I would like you to now apply this process to traffic lights. The final deliverable is that there should be a traffic light app where I can click on the traffic light and it rotates between the three colors. All right, let's go.
Got it. Alright, just I'll fix that later. I was like trying to put these over to my notes. Anyways, okay.
Oh. Oh yeah, so whenever you modify, you got to tell me where you are. I can't actually
Oh,
find you.
I went up to 162, which is like the last
162.
things I was doing
Okay.
under for traffic light. Eh, mm, uh, so I'll bring all this code up just so I can on mouse to Okay. Wait, went too far. Let's see. Uh, I'm looking at the code at the bottom. Bear with me.
Mm-hmm. I think on Visual Studio, you can split screen as well to see both at the same time.
That's a good idea actually. Okay, let me just extend this. Okay, yeah, that's helpful. Now for this part on mouse,
Mm-hmm.
when you came up with that phrase on mouse door, oh, I see. That's literally from, okay, because you made that function above. Okay, I
Yep.
see.
Yeah, the name could be anything, but try to have it make it descriptive.
Exactly. Cool. We'll call this oh wait, we need a bit more than that, don't we? Um,
I'd like you to write a signature as well.
okay. I mean, I guess it's the same as before, no?
So what is this
Right.
function doing?
Um, kind of rotate through the traffic light, so it goes from traffic light to traffic light.
Hmm. Wait, that already exists, right? That's a line.
Um,
We did this before, right? The 196.
yeah, but we're not on mouse click.
So this is a version for mouse click, right?
Yeah.
Okay. So I'll like the word mouse to be somewhere in the title.
Okay.
Like maybe mouse true lights. I don't know. So the first thing is naming. So it needs to be clear that this has to do with mouse inputs. The second thing is let's look at on mouse door. How many things does on mouse door take in?
It takes in a lot, yeah. That's what I was like having to figure out.
Okay,
Um, so just thinking like, okay, so X and Y represent the two different positions that they could
X and
be
Y. Yep.
in, and then door represents the actual image itself.
Door is open or close, like the string open or close.
Okay, so really
Yeah.
just one position, and then what is X and Y exactly? Like,
X and Y coordinates. That's mouse positions.
okay, okay.
So you want to
So
copy
so
over
it's
the
always gonna
signature.
be
Yeah. This function will always take in four things. The last three things will always be the same. It's always going.
a.
Okay, sorry. Yeah, so the signature is always going to be the same. The
Mhm.
last three things will always be a number key event.
Got
But
it.
the first thing though is not going to be a door this time.
Yeah, it's traffic light position, and so now I understand with X, Y, and key event is the click itself, right?
A key event is the type of event. So there's button down. There's
Okay.
also button up. There's drag. But let's just use button down. Let's keep it simple.
Yeah.
Oh, could you write the signature for our function?
Sure. Let me see what you door number, number, key event, door. Okay. Like, so, okay, your signature is just like your signature. What are you trying to say in your signature? It's basically just like going through all of the different inputs or that are being input into the function, and
Yep.
then like what the result is. Pretty much it.
Yep, exactly. Yeah.
Okay.
There's one more input. Okay, for consistency, let's have traffic light be one word, a key event be one word. So there should be no space between them. It's not underscore either. It's like traffic light, capital T, capital
Oh.
L, and no underscore.
Oh. Okay. Why? Like I know I put an input up there. This is how I had it done. Why does it need to be like this specific way for the signature? If you
So
could
if we
just
look at
walk me through.
line, let's see which line it is. line 64. That's how the like we need to use the exact casing that we used before so that everyone knows we're referring to the same thing.
I see.
Remember, just now I mentioned that the name is how we know which circle we're talking about.
That's just one of those things. Like I know it's like that because you wrote it, because I would never write it that way.
Oh,
You know what
it's
I
also
mean?
convention. Like we haven't gone to types yet, but when we work with types in this language, all the types are, I think it's camel case. I forgot the like title case. Yeah.
I got you. Okay. So
So like
even
just for
even
habit, let's have
signature.
key event as well. Key event is one word, no space in between.
Got
Yep,
it.
perfect.
Okay. Okay. Oh wait, haven't or okay. Oh wait, they right.
Nice.
Something like that.
Nice.
Okay. That looks all right. Um, okay. And then is this like good enough to run now? Oh, the inner part. Yeah, yeah, I knew that. And yeah, actually, yeah, the way anime parts not. Okay, I got this. That's fine. Um, so init, you said init is short for initial.
Yes.
Um, help me understand this a little better so I understand like what's happening here.
Hmm.
When I think of init, like I think of like Python classes and setting up methods. Where you're like init and position close. Like what are we? Is it like why?
Uh,
Why does that make sense?
forget Python classes. That's completely different.
Hmm.
In our case here, so the animate, it needs something to draw, right?
Yeah.
Okay, what's the first thing you wanted to draw?
Okay, so um basically basically you're telling it like which um where you're starting basically with
Yes.
also like initial. Okay, this is gonna be silly. When I thought initial, I'm thinking like initials of a name, like
Oh,
ES, not initial like the beginning.
yeah,
So
yeah.
that
No,
was like
beginning.
this doesn't make sense. What does this mean?
I see.
Okay,
Okay.
initial position.
Yeah.
And then on mouse, and then it does the animation, and then what it's drawing. Okay, okay, cool. Now I understand. So I guess we'll start on red then. Yeah,
Yeah. I mean, when you end up at a traffic light, it's always red, right?
sure, makes sense.
Especially when you're in a hurry.
Yeah, and then do I need like parentheses after all these? I guess not. Would I need a comma after this, or just over these first two lines? I'm
Um,
sorry. 173.74 has a comma. Does 175 need a comma?
No, but if I'm not wrong, you can add one. It just ignores it.
Okay, that's fine.
That's like a debate. Like, do you add a comma on the very last item? That's like a big debate.
Let's see. Okay,
Ah, okay.
okay. Mine's
Oh,
not animating on click, but probably just gotta
okay. So yeah,
fix it.
nothing's happening when we click on it, right? Why is that?
Just gotta figure it out. Hold on.
Okay, so let me
Did
actually.
I did I put in the wrong formula or the wrong function? I might have.
No, the functions are correct. Okay, it's time I show you the documentation for this, because the
Okay.
problem you face is the one I faced just now, and the way I fixed it is by reading the documentation. So I'm going to talk
Oh,
about
wait,
that.
wait. I think I literally, yeah. I think I literally, yeah, you told me that.
Oh,
I think I
oh,
fixed that
okay.
somewhere.
You
Okay,
and
now it
I,
works. All right, cool.
both of us. All right, so oh, nice. You see
All
that?
right, that works. Yeah.
Cool. Okay, I'm gonna yeah, you know what? I'm not gonna talk about the documentation because I'm gonna move on from this. But I
Hmm.
will, if you're curious about this and you want to learn more, and you want to do crazy stuff with this, I'm gonna link you the documentation as an email later,
Hmm.
okay?
Yeah, go. Yeah,
But
that sounds good.
we're gonna pause on this for now. We're gonna move on to a new topic.
Okay.
Okay, so actually, let's talk about how you organize your files. Do you want to like do it by dates, or would you rather that I create like a new file for every new topic?
Um, yeah, we could do like a new file for new topic. I was just that made sense for me at the
Okay,
time, but it doesn't seem like it's gonna work for how you organize the class. And
okay,
so yeah, I'll try. I was gonna rename that file like to encompass more than one meetup, like 8.3 or
okay.
8.17 or something.
I want to create a new file just because this file is like has a lot of stuff going on. Like, when you click
Yeah,
run, we get a bunch of images and it plays a bunch of animations. I'm going to
yeah,
create a new file at the top and you can decide where to put it. I'm going to call it
sure.
mm, intervals.arr.
Okay.
Okay, so a bit of lecturing from me now, so I'm going to talk aloud. So the whole idea of creating a data definition is that we're taking some piece of information in the real world and encoding it into a program, right? So that the computer can work on it. So when we first began, we worked with just encoding it as a number, right? For example, temperature. You remember that?
Hmm.
Next, we moved on to something a bit more powerful. We saw enumeration, where we can say it's one of three things or one of two things. It's either red, green, or yellow. It's either open or closed. Okay?
Yeah.
So we call this forms of data definitions. So a form, as in like the general structure of a data definition. We saw two. We saw primitive. We saw like a primitive data definition that just uses a single number. We saw enumeration. Okay, so forms of data definitions. So far, primitive. We also saw enumeration, one of X things. I'm gonna introduce a new one now, intervals. So let me give you the situation, and which might be all too familiar. Let's say we are a tax collecting, let's say yeah, we're a tax collecting company and we have software for taxes. Let's just say, like, I'm not sponsored, so I'm not going to name those products, but there are a few software online, especially for the US, where you can file your taxes with them and they calculate your taxes, right?
Yeah.
Yeah, so let's say we're one of those companies. So the information we want to encode is people's incomes and tax brackets. Let's just say for now. So here's the situation. Oh, we are a tech software company. Uh, and we need to encode tax brackets and income. Now, of course, in real life, it's much more complicated than that, but let's just say that's what we are going with.
Yeah.
Let's just say tax income brackets. I don't know what's the exact name, but what I'm talking about, right? Tax income brackets.
Yeah. That's correct. You're good.
All
That
right.
makes
So
sense.
let's say if you earn below, let's say like $5,000, I'm not going to use actual numbers here. I'm coming out these numbers on the spot. Uh, it's a 0% tax. If you make anywhere between 5,000 and here, let me. So this is not code. I'm just trying to convey the information. Okay.
Yeah, yeah, I get it.
Let's say if you're between that range, you do 5%. And let's say, oh, let me do this actually. 7,500 and let's say 10,000. We do let's do 10%. Otherwise, we do let's say 15. Okay, I want to break the pattern. Let's say 16%.
Okay.
That's kind of funny. Let's do 21%. Okay. So here's the situation. Um, so first thing we do, oh, let's say our task is to given a an income, we want to compute the tax percentage. Okay. So I'm going to follow the design recipe. Okay. And so there are things here I want to emphasize. I noticed there are certain steps you are skipping, and so I want to take this opportunity to emphasize what those steps are. So the first thing we want to do is we want to design a data definition. We want to be able to talk about income relative to tax income brackets. We want to encode that information as a data definition, right?
Hmm.
So the first thing I'm going to do is I'm going to say a tax income bracket. So notice how I'm using one word title case as convention.
Yeah.
And notice how we have one of many possibilities, right? So I'm going to say it's one of. Okay.
Okay.
Um, and here I'm literally going to, sorry, give me 1 second. I want to read how the textbook does it. I want to follow the format. No, not that. Yep. Okay, so the convention I'm going to use here is I don't know if you have seen this before. Square brackets and round brackets. Is this familiar?
No.
Okay, so in mathematics and occasionally in programming, you might see this syntax, well, this convention. Square brackets is inclusive, round brackets is exclusive. Okay?
Okay.
So in the range 5,000 to 7,500, it ends with a square bracket, right? So we include 7,500 in that range, but 5,000 is not included. Okay?
Yeah.
So, okay, for the number 5,000, which range does it belong to?
It belongs to the bottom, that first one. Well, I guess in this case, top.
The first one, line 22?
23. Or yeah, 22, 22. Blah.
Yeah, okay. Okay, good, good. That's important. Next, following this. Yeah. And infinite INF is infinity.
Okay. Okay.
So you
Um.
might also choose to use this, like at most 5,000, or at least and excluding 1,000, 10,000. You could also do that. Like you don't even have to use like math notation. You can just use English, like
Yeah.
5,000 to 7,500, excluding 5,000, right? Uh, Here I'm going to use a mix of both. Okay, so this is the first step. So the first step of the design recipe is to design the data representation. So that's our data representation. How are you representing that information? Next is interpretation. So this one I noticed that you missed. So keep this in mind, interpretation. So represents tax income brackets. This represents a tax income bracket that a person would belong to. For example, doesn't have to be fancy. What's the next step of the design recipe?
Um, well, I guess the initial function because we do the template after, right?
Uh, okay, there's something before templates. What is that?
Signature.
Oh, okay. So you're thinking about functions, right? But still on data definition. There's something we can do about that data definition.
Where we identify the variables.
Examples, right?
Sure.
Yeah. So here I'm going to use the convention TIB for tax income bracket. And so for enumeration, you just have one example per case, right?
Yeah.
But here's the thing about intervals. You can actually have multiple examples per case now, right? For example, we have 5,000, we have 100, right?
Sure. Okay.
Always have zero as an example when it comes to numbers. All right. Okay, let's leave it at this for now. We are out of time. I'm, if you would like, make more examples and try to write the template. So we haven't covered the template yet. I will give you a hint, similar to enumeration. I will also send you to a link on Big Bang. Sorry, not Big Bang, Reactor. And you are welcome to do random stuff. Just play around with it. No, it's fun, right? It's fun to just do random stuff and be able to play or like make small games and play around with it.
Yeah. Sure.
I'll send you the documentation on Reactor. Okay. All right. Let's wrap up here.
Okay.
Sorry to leave you on a cliffhanger, and we'll pick it back up next time.